All right, so let me begin the session. Good morning, all. So, what's the last topic which we have seen? What kind of sorting method we have seen in the last class? So we basically done with yeah. So we have done with three sortings until now. One is bubble sort, insertion sort, and selection sort. Right. Um, then the next thing is we will talk about. I'll talk about merge sort. Right. Um, so merge sort is easy. This is the easiest. I mean, let me just check it here. Yeah. So there are some responses in the chat box as well. That's good. Let me share my screen. Hope this is visible. Yeah. So we have seen bubble sort, selection sort, quick sort as well, and insertion sort, right? So four things we have done. So the last sorting method is merge sort. So merge sort, the name itself says that we're gonna merge. So we're gonna perform sorting, and then we're gonna merge. So we have already seen that um, quick sort that is a little bit lengthy. It has got we have to compare the values.
Yeah, yeah.
And we have performed swapping, and then based on that we will we will introduce, we will pick the first element, and then we will say I and j from the left and right, and then we keep on comparing. When I and j crosses, then we will replace pivot, right? If there is no crossing, then we will just replace those I and j elements. So that's how we have done, right? Quick short. Okay. So
One did one.
we just left with merge sort and two searching algorithms, okay? Sequential search and binary search. So today I'll talk about merge sort, okay? So merge sort follows divide and conquer again, okay? Divide and conquer technique. So divide and conquer, in the sense, you will be given a list of elements. First, you need to find the mid position, and then split the array into two subarrays. And then again, you have to split it. For example, if something is given like this, I'll take some numbers here. Let's say 185, 65, 7, 10, 20, 7, 8. Yeah. So these are all the sequence of elements which is given. So basically, in all the sorting methods, the final result is like ascending order, right? So from one to, I mean, in increasing order, you need to sort, is it? So that's the agenda of all these sorting. But we follow different techniques. That's it. So in merge sort, as it is divide and conquer, first what you have to do is that you have to find the midpoint, and then you have to divide it. So now what is the midpoint? How to find the midpoint? So these are all the sequence of elements which is given to you, and based on the index, like um, yeah. So here I'll just take, this is one, first index, second index, third index, 4, 5, 6, 7, 8. Okay. So what you will do is that, and here in the left side it is called as lower bound, LB. Okay, lower bound, and this is called upper bound. Okay, that is UP I have taken. So what you want to do is that is to find the midpoint, you need to say that lower bound plus upper bound divided by 2. So that is, what is the lower bound? It is 1, and then 8. Oops, sorry. The array index basically it starts from 0, right? 0, 1, 2, 3. So in that case, you will get 0 to how many elements? So 0, 0, 1, 2, 3, 4, 5, 6, 7, and let me add one more element here, like 90. So right now there are 0 to 8. So what I will say that lower bound is 0 plus upper bound is 8. So 0 plus 8, then that is 2. Then I'll be getting what? 8 divided by 4. So now I need to split this. So where is 4? So 0, 1, 2, 3, and 4. So this is 4. So I will give a cut over here. Now I will split this as one separate subarray, I mean 0 to 4, and then I'll split this as another subarray. So merge sort, I said that it is divide and conquer. So to divide this, first you need to find the midpoint, right? I mean the lower bound plus upper bound divided by 2. That's the formula. Okay. So once you have divided this, then further you have to keep on dividing until you get a single element like this. So how can you divide it again? You see this, if I take this one, uh, like 1, 8, 40, sorry, 65, and 7 and 10 is there, right? So I need to still divide this in case, again, I need to apply that 0, 1, 2, 3, 4. So it's basically like a tree. For example, you will get these things first, then you will take it as 1, 8, 6, 5. Then again you will take like 1, 8, and like this. Then finally you will divide this as 1 8 can be divided as 1 and 8. So after this there is no further dividings. I mean, after this you can't divide anything. So that is how you need to divide all these things. Then you need to match these things. For example, here 1 and 8 is there. So what we said, divide and conquer. First you need to divide all such things like this. Then you need to merge. I mean sort and merge. So this will be in sorted order. So now I'll take these two elements. I need to merge. I need to merge this also. This one with this one. So I'll be keep on going from the leaf node to the root. So root is here. So I'll start merging this point first, and then with this one, and then this one, and then I will add. So in the right side, I'll be having this element, 7, 10, right? So I'll be merging that also. So I'll be getting one sorted, what do you call this, array here for this left side subtree. Then if I split this 20, 30, 80, 90, again I'll be having another sorted one. Then I'll be just merging these two. So I'll be getting a sorted array of this elements. That's it. So this is what we're gonna see. I'm just giving you the logic. Uh, um, how we're gonna perform merge sort, right? So let me just take an example. First, I'll write an algorithm and then explain how can we do this. So you need to keep these points in your mind. Merge sort is divide and conquer. Again, it is a recursive algorithm. We're gonna have two parameters, right? That is lower bound and upper bound. So in an algorithm, we need to pass all such things. I mean, two parameters will be passed. Fine. So if I say, let me say a merge sort. Okay. So I said two parameters I'm going to pass. So this is a function. This is lower bound, and okay. I mean, I'm taking low and high. That is lower bound and upper bound, higher bound. Okay, then what I do, if, okay, if L lower bound is less than the height, okay, then what I should do is that first I need to find the midpoint. Okay, that means if you have got some list like this, 9, 3, 4, 5, okay, then the indexes are either you can, I mean, this is for our reference, you can proceed with 0, 1, 2, 3 or 1, 2, 3. Okay, but if I take this as 1, 2, 3, 4, then you see this 1 plus 4, that is 5 divided by 2, you will be getting 2.5. So you will be splitting it here, right? So that means here this lower bound is 1, upper bound is 4. If the lower bound is less than upper bound, obviously 1 is less than 4, right? Then you see this, we need to find the mid. So how I have found the mid here? Just now I said lower bound plus upper bound divided by 2, is it? So the formula for mid is again L. That's what I did now. L is 1 and I mean the upper bound H is 4 I have taken. So I'll simply add that one, L plus. My algorithm should perform this task. That's why I'm writing this formula, right? So once this mid is, I mean mid value got found, then what you do is that you just want to split it, is it? So 9, 3 is there. So I said that you have to split until you get a single separate element. Okay. So again, this 9, 3 will be splitted as 9 and 3. I mean divided. Okay. So that's what. So likewise here 4, 5. Then 4, 5. So after this, there is nothing to divide. So now, so dividing is done. So now while merging, sort and merge this. So here comes 3 and 9. This is already in sorted order. So here comes 4 and 5. Okay, so now you got these two different subarrays. Now you have to merge again these two things. So again, this should be in sorted form. So it should be like 3, 4, 5, and 9. So your algorithm will perform this one automatically. So now I'm just talking about this example, okay? So what if your algorithm is lengthy? Then see, after sorting it, I have merged it finally, right, in a sorted order. So likewise, you just want to perform the task. So for this, again, what should I do is that I need to call, I'm writing, okay, merge, sort, that is, first what I did, first I'm concentrating on L side, I mean lower bound side, right? So how I'm performing that? I need to take lower bound and then I need to take the mid of that. I have taken the mid value, is it? Then that is in the left side. That is in 9 and 3. For 1 and 2, I have done the same thing. I have taken the lower bound, and for example, here there are only two elements. If I take the mid, it will be like this only, right? 9 and 3, because 2, 0 and 1, right? So if I found the like L plus lower bound plus upper bound divided by 2, then I'll be getting a mid over here. Then I need to divide this whichever is there in the left side and right side. So in the left side I have got only 9, so I'll put that, divide that 9. The right side I have only got 3, so I'll do that. Is it? So that is how you have to perform in the left side, I mean in the lower bound side. Then in the upper bound, again the same, merge, sort. What it has to do is that is mid plus 1. I'll write mid plus 1, comma. Now for which I'm doing higher bound, that means upper bound. So I said that this is lower bound and this is L and H, or you can take as lower bound LB or UP, whatever it is. See this, why I'm saying mid plus 1. See, mid is, here we have got 2.5 as mid. Now after finding the mid for the first sequence of array which is given, so you will see now this is the mid 2.5. So I'm just taking the left side value, that is 9 and 3, and then splitting it, right, dividing it. Then how your algorithm will go after mid? It should read after the elements, I mean the elements which are after the mid point, is it? So that's why I'm saying mid plus 1 means whatever is there after mid, it should be considered as higher bound, is it? Okay. And finally, after dividing like lower bound and then upper bound values, then what we are done here, we have added both lower bound and upper bound, which means that we have merged both upper bound and lower bound, is it? So again, I'll say merge sort. Simple. So what I have to do first, I have added what? Lower bound, that is 3 and 4. I mean, I have sorted this one up 3. So that values I need to merge, and then I need to merge with the mid, then higher bound. So these 3 things should be taken. So final list. So this is about the final list. That's it. So simple algorithm. So what we're gonna do is that we're gonna pass 2 parameters. Okay, that is lower bound and upper bound, or lower or higher, whatever you wish, you can take it. So and then we just want to compare it. If this lower is less than height, I mean lower bound is less than upper bound, then find the mid. Okay, that is L plus H by 2. You just take the index, okay, and then you just perform it. So you will be getting, so you can mark a center point over there. Then whichever is there in the lower bound, again, for example, you need to find the mid of this 9 and 3, because we need to split until we get a single element, right? I mean, we need to divide until we get a single element like this. So now this is 9 and 3. So if I find the mid of this, it will come like this. Then 9 and 3 will be separated. Okay. So after this 9 and 3, I can't separate because it is already done. We have reached the single element over here, right? So like this, you need to perform all the dividings for the left side. Then you just go to the right side. That is 4 and 5 here. That should be done in the same way. Mid plus 1 in the sense I want to read something after mid. I mean, I want to read even after mid, right? So I'm just saying mid plus 1. That's fine. And then this is higher bound. So whatever is there after mid, then that is higher bound. So you just perform the same, right? And finally, we need to merge it. So this algorithm is really simple when compared to all other algorithms, I guess. Is it? Hope you can understand this. Fine. So now I'll just take example, and then we'll just perform the task. Just allow me to just cut it. Okay. So let me take an example here. So what should I do is that anyhow, we will see this topic again once with PPT. I'm just going with like whiteboard today. 9, 3, 7, 5, 6, 4, 8, and 2. So these are all the elements which are given to you, right? And what you have to do is that let me. So if you yeah, as I said that you can start from 1 or 0. Let me start from 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so these are all the elements, and so now this is lower bound, okay, and this is upper bound. You can write LB or UP or L or H, okay. So from the given element, so we need to find the mid and we need to split it, is it? So where does it comes if I do a split, if I apply this particular line here? See, merge sort, I have passed two values, L and H. Now the L value is what? 1 and H value is 8, is it? So if L, that is 1, less than height, that is 8, 1 is less than height, is it? Then what happens? It should find the mid. How to find the mid? L plus H divided by 2. What is L plus H? 1 plus 8 divided by 2. What is that? 9 by 2. Then with 4.5 you will be getting. So which means that this is in between this one, right? So I need to draw a line here. So which means I'm going to split this 9375 as one subarray and 6482 as another subarray. Is it? Right? So let me first give you, I mean, whichever I'm going to do right now, it is not mandatory to mention, but for your understanding, I'm just showing you. You just want to split this part only. You have to name 9375 and then you have to perform it. But I'm just taking the index right now and then I'll show you what happens. See, what is the lower bound? That is 1. Upper bound? That is 8 here, is it? So what we have to do? I mean, we need to find the mid, is it? Lower plus upper divided by 2. So now if I do that, I have found that it comes like this, 4.5. So I'll be having a line over here. So now what I have done is that I need to take which values from which index to which index? From 1 to 4, I need to consider in the lower bound side, is it? So I'll take 1, 4, which means that these values I'm taking right now, 9375 is taken. Here I'm just writing the index. Fine. And in the right side, what I have got? So from 5 to 8, is it? That is in the upper bound. Okay. Then I said that we need to divide this until you get a single element, right? So now in 1 to 4, 1, 2, 3, 4, right? So again, this is the lower bound. 1 is lower bound. And what is this? 4 is upper bound. So again, you need to find the midpoint. So 9375. So 1, 2, 3, 4. Out of this, which is the midpoint again? If you have just 4 elements, just say that you'll be obviously getting this as mid, because 1 plus 4 is 5. Divide by 2, 2.5. So somewhere here, right? So again, you see this? Again, how this index will be splitted? Here I'm talking only about the index, 1, 1, 4. So which means that I need to take we have not done quick sort. Oh, we have done for okay, EC2 we have done. Fine, no problem. We will do that one in the next session. Right? Okay, then one sort will be pending. You guys didn't let me know about this. I mean, when I was saying, only one have responded. Okay, fine. That we will see, because quicksort is little bit difficult. I mean, not that much difficult, but it is not actually quicksort. Okay, I mean, there are some steps. The algorithm is also a little bit lengthy when compared to these the rest of the sorting methods which we have seen. Okay. So right now I'm just showing you the index, right? I'm just playing with index. So if I do this one, I said that 1, 2, 3, 4 is there. I mean 1 to 4. If I find the mid, it will be like 1 and 2, is it? So I need to separate. I'll have 1. So from here, it will be like this: 1, 2, right? And then here it will be like 3 and 4. Is it? I said that we need to separate until you reach a single element. Now we have got 1 and 2. See this 1 and 2 index, which means 1 is lower bound, 2 is upper bound again. Again, you need to find the mid. That is 1 plus 2, 3, 3 by 2, 1.5. Again, you will be getting like this, right? 9 and 3. So which means 1 and 2 will be splitted again. So if you do that one, you will have only 1 here, basically 1, 1. Okay, and here you will have only 2, right? So further, is there any possibility of dividing this? No. So we stop here. Again, 3 will be splitted and 4 will be done like this, right? The same steps I'm applying here. So you see this, Here in the right side, that is upper bound side, we said m plus 1. Why we said m plus 1 here? Because I need to take those values which are after mid also. That's it. So I need to consider whichever. So we just found mid already, and then we have splitted it, and then we have taken all the left side values in lower bound, right? Okay. So now m plus 1 in the sense like 4 plus 1 is 5. So from there, it should consider it as higher bound. So 5, 6, 7, 8. The index number 5, 6, 7, 8. That means these elements 6, 4, 8, 2 will be considered as higher bound. Okay. So now again, from this 5, 6, 7, 8, 5, 6, 7, 8, you see this 5 is lower bound and 8 is upper bound. Right? Again, it is less than L less than height. I mean L less than upper bound. 5 less than 8. So you need to again find the midpoint. If you do so, you will be getting here, right? So which means 5 and 6 should be divided, subdivided. I mean 5 and 6th index. So I'll be writing here 5 comma 6. Then here you will be obviously getting 7 and 8. So still, is there anything? Yes, you see this 5 and 6, L and upper bound, lower bound and upper bound is there. Still, I said that we need to divide until you get a single element, right? So if you do this, and you will be getting, see, for example, 5 and 6 in the sense, the midpoint will be like this because of I'm taking 6 and 4, the elements. Right now, I'm just marking index only. Then what happens? So 6 will go on the left. That means this in the index, the 5 will be in the left, and then 6 will be in the right. Then here, again, here, 7 and 8. So this is how we need to divide. So until now, we have done only division, right? So, okay. So once you have divided, then what happens after that? What we actually have to do? Yes. What sort of things we have to perform here? So now let me write the values for this. So the values are in index number 9, what we have, sorry, index number 1, what we have, that is 9. And index number 2, we have got 3. Right? These elements. Fine. So now what happens for this? Now this particular thing will be sorted, 9 and 3. Sorting will be applied. So it will be stored in this format, 3, 9. Okay. So now what are the values in the index? 3 and 4. This is, and this complete diagram shows, I mean complete tree diagram shows only the index values. Okay, for your understanding, I have taken in this format. Okay. And 3 and 4. In 3 and 4, we have the values like 7 and 5, is it? So 7 and 5. So this will be, so we are performing merge right now. That means here, this step, merge sort L comma mid comma H, which means lower bound and then mid and then higher bound. So if you want to reach the mid, so we have to start from the leaf and then we have to keep on merging. So 7 and 5, that will be stored in this format, 5, 5 and 7. Okay, so now these are our two subarrays, right? Two subarrays. Now again, this part should be merged. You see this, after this 1 comma 2, 3 comma 4. Then you see this here, I need the merged one. 1 and 4 I need to merge, which means this 3. See, I'm starting from here and then I'm moving like this, then I'll go here. Right? So basically merge sort follows post order. For your information, this is very important. It follows post order traversal. Okay. So see here 9 and 3 got sorted, and this is one subarray I said, and this is another subarray. Again, this will be merged in this step. When you come for this step, so 3, 9, 7, 9, which means that this will be, while before merging, it should be in a sorted form. I mean, it'll basically store in a sorted form. So out of these elements, you see this 3, 5, oops, 3, 5, and 7, 9. So now we have got one side of things, which means that here at this point these things have got merged. Okay, so 3 5 7 9, we have sorted what we have sorted. This point got sorted, is it? So now we go for higher bound. So here again in fifth and sixth index, what are all the elements we have got? That is 6 here, and here it is 4, and in seventh index I have got the element as 8, and in eighth index I have got the element as 2. Again, you just want to apply the same, which means now we need to merge. So 6 and 4 will be merged as in a sorted form, 4 and 6, right? This is one subarray, and here it is like 2 and 8, right? Another subarray. Then I need to merge again these two things. So, I mean in this step, okay, this step is over now. So when you come to this part, 5 and 8, you need to, merge these two, and then because left, mid, and high. So what happens here? It will be basically in a sorted form again, 2, 4, 6, 8. Now we have got this one. So here, so this is the left subarray, and then this is the right subarray. So here, finally, you need to merge here 1 and 8 in the sense combining all the elements. So again, this part will be merged again because as I said that it is recursive. In a recursive algorithm, it is going to repeat these 3 steps, right? Recursively. Fine. So finally, you will be getting a sorted list. That will be like we know the result. Like it should be in ascending order. So it should be like 2, 3, 4, 5, 6, 7, 8, and 9. So this will be your answer, the final answer, right? I just written this algorithm, and then I'm just showing how it is performing these steps, nothing else, right? So this is a simple algorithm basically. So you need to have 2 parameters, right? L and H, that is lower bound and upper bound. Okay, so that is what I'm passing here. If you see in the algorithm, it is like merge sort L and H. I'm passing that, right? I mean lower bound and upper bound value. If this L is less than height, right? Then you need to you need to find. I mean L and H in the sense lower bound is now I have taken here as 1 to 8. So here I mean the index, right? So the L value is 1, and it is less than 8. 1 is less than 8, right? Now, if it is less than 8, then you need to go to this step. In the algorithm, I have written this step. Mid equal to L plus H divided by 2. So L plus H, L value is what? 1 plus H value is what? 8 divided by 2. So 9 by 2, right? 4.5 you will be getting. So you see this in the index 1, 2, 3, 4, 5, 6, 7, 8. I will draw a line in between 4 and 5, right? Which means it splits the given element into 2. So now it is splitted as 9375 as one subarray, 6482 these elements as another subarray, right? That's what we get in this step. We have splitted. Yes. Once splitted, so instead of splitting index, now you just want to write those elements. Why I have written index? Because I want to show you that how it goes through, and then finally I have matched with the elements, right? Even you can follow this procedure, or directly you can split. You can write those elements instead of index. Okay, instead of writing 1 4, you can say 9 and 5. Up to 9 and 5 it is in this part. Then again it is splitted. So I said that we need to split all these things until you get a single element like this, right? So once if it is done, then you just match with the elements and then put it in a sorted order, and the elements will be arranged. So basically these 3 lines, you see this, once you find this mid, okay, then we have a lower bound or upper bound values, right? So you have to go to this, I'm calling this merge short again. That is merge short L comma mid, means whatever is there in the left. See here 1 comma 4 is there. Again, I need to find the mid of this. Then again split until I get the single element. Then once this left part is over, I mean, once you are done with this, this left side, then mid plus one I'm saying. See, in the for algorithm I was talking about m mid plus one, comma height, which means higher bound. So whichever is there after mid, so that is considered as mid plus one, and then I mean that is in upper bound. So again you need to go for the right side, and then you need to perform this task, which means again you have to perform. So again the algorithm calls, again it compares L comma H, because when you take the 6 4 8 2, these elements, again here it is like L and lower bound and upper bound, again it will find the mid, then keep on splitting it. That's how it goes. Then finally you will just add all such things, merge. So we are because if the problem is, see, why we call this as, I mean, why it is using divide and conquer technique, in the sense that if a sequence of elements are lengthy, in previous sorting algorithms we have not splitted this one. I mean, you will be given a list of elements, right? And there will be number of elements. You will be comparing like this, then you will swap. You will be comparing, you will swap. In bubble sort, we did the same, right? So we won't divide this one. So now if you divide and then if you do this, you need one more array. For example, this is, I'll take it as A. Then this elements will be stored in array B, because we are dividing it and then we are storing, I mean, sorting and storing it. Nah? So we need to have one more array. Finally, what happens? This will be copied. This array elements will be copied to this array back. So in the single array, you will be getting the output. No problem. But here in bubble sort, what we do is that we will compare the adjacent elements, and then we will keep on moving further. But that is difficult, because if you have 100 elements, then if you split the list into two and then again split the list, that particular left and right things again into two like that, then it will be very easy for you. That's why divide and conquer. You might have heard about this cow and lion example, right? If 4 cows are there together as a group, a lion can't attack, right? What the lion will do, it will get scared, and then these 4 cows will kick off that lion. The lion will go off, right? But what the lion will apply, that lion will, in a forest, it will just apply divide and conquer rule, which means it should separate these 4 cows by doing something, or it should attack. Only one particular cow is there. If there is one cow is there, then it is easy for the lion to attack, right? So that's what we are performing here. So we are dividing the element, I mean the elements which are given, until we get one single element here. Then it is easy to sort, right? Once sorting is done, then it is easy to merge, because the sorted values can be merged. So that's what we are performing here. I mean, that's what we are actually applying here, applied here. So that's why the time complexity is measured, measured in log. Okay, so you can refer the table which I have given. So here it is as log n, because we have n number of elements here. Where? Yeah. So here we have got n number of elements. We need to we need to take all these n number of elements. So that's how it goes. All right. So I'll be doing one more example in the next session. Then we will see quick sort, right? And then we'll proceed to the next upcoming concepts. So is there any queries in merge sort? Did you understand the flow, how we are doing merge sort? A sequence of elements will be given. You just want to find the mid by saying that left plus height, and then divide it, and then divide it. Keep on dividing until you get a single element. Then apply those values. I mean, mention those elements in that tree, and then perform merge, and then sort, and then merge, right? Merge small subarrays. So left subarray, right subarray, which will be merged. You'll be getting the complete left bound. Then you go to the right side. Then it will be done. Then finally go to the root, and then it will be done. Okay. So let me go for the attendance now. Please do answer.